In the name of Allah, the most gracious, the most merciful, praise be to Allah, and peace and blessings be upon the Messenger of Allah, our Prophet Muhammad, and upon his family and companions. Now let's continue with a new lecture on current and voltage transformers. We will now begin to delve into the world and details of voltage transformers. Voltage transformers are used to obtain a low standard voltage to supply protection, measurement, or control circuits that require voltage to operate. This standard value for the voltage transformer, known as rated voltage secondary, is either 120, 115, 110, or 100. Typically, 110 or 100 is used in Europe, while 120 or 115 is used in the United States and Canada. In the US and Canada, 120 is commonly used in the distribution system, and 115 is used in the transmission system, and 115 in the transmission system. As for the relays that primarily need to be inside, they include, in addition to voltage, under voltage, over frequency, under frequency, directive over current, directive earth voltage, and distance relay. The digital multifunction meter and energy meter primarily require voltage. Control circuits needing voltage signals include load shedding, synchronizing check, AVR, ACCS, ABTS, and ACSE. We'll discuss these in detail later. Voltage. Transformers are either metering or protective. Metering voltage transformers offer high accuracy, with class 0.5 indicating a plus 0.5% error at the highest burden. Protective transformers, noted as class 3B, have a plus 3% error. Higher class values indicate higher error ratios. Voltage transformers are split into metering and protective types. Metering types are class 0.5 with plus 0.5% error. Protective types marked B are class 3B with plus 3% error. Higher class values mean more error. Voltage transformers differ from power transformers. Both work on the same principle, but voltage transformers have capacities in tens of volt amperes, while power transformers exceed 300 megavolt amperes. When the letter B is mentioned, indicating this transformer is for protection, it's noted as class 3B, which tells us this transformer is for protection, and the error ratio is plus 3% of the rated voltage at the highest burden. We notice the higher the value next to the class, the higher the expected error ratio. Voltage transformers for protection, measurement, and control differ from power transformers used as step-up or step-down voltage. Although both types operate on the same principle, there are differences. One difference is the capacity of the voltage transformer may not exceed tens of volt amperes, while the power transformer can exceed 300 megavolt amperes. Additionally, voltage transformers do not require cooling, whereas power transformers need a complete cooling system due to their high capacity. Also, voltage transformers do not require cooling, while power transformers need a complete cooling system because their capacity is high. So, one of the differences is the size, where the power transformer is much larger than the voltage transformer. The voltage transformer is symbolized by VT, while the power transformer is symbolized by... The power transformer has no abbreviation, so I can't say that the abbreviation for power transformer is BT. The voltage transformer is represented by either VT or BT, where VT stands for voltage transformer and BT stands for potential transformer. There is a very important note that voltage transformers are required to produce a secondary voltage that closely matches the primary voltage, which requires minimizing the voltage drop across the VT. On the other hand, the power transformer is required to transfer power from generation to transmission and from transmission to distribution. On the other hand, the power transformer is required to transfer power from generation to transmission and from transmission to distribution.